Good afternoon and welcome back, everybody, to this stakeholder webinar on the European Strategy for Offshore Renewable Energy. So my name is Michela Marasco and I am a policy officer at DG Ener in the Unit C2, which is the unit responsible for innovation, clean energy technologies and competitiveness. So I'm very happy to be here this afternoon to be able to introduce you an exceptional panel of stakeholders from the industry and also from the research and innovation side to discuss what is another key element, which is going to be at the very core of the offshore strategy, which is the strengthening of a European double leadership, which is a leadership, an industrial and a technological leadership in the area of offshore grids. So it's a matter of supporting a European competitiveness, it's a matter of promoting the possibility of new jobs, of promoting European industry. It's also a matter of making sure that the most promising innovative technologies and solutions which are developed in European lab are tested also in real life, let's say, and they're also brought very fast to the markets, because only by deploying, with the massive deployment of innovative solutions, we can really achieve European decarbonization objectives. So before starting with the presentation, let me remind you some of the practical aspects. So I would like again to ask all participants, except from the speaker, to remain muted and with your camera off during the entire session. You can, of course, actually, we will encourage you to ask as many questions as possible. So please, for this, use the chat box and address them to the moderator, which will then send it on to me and I can ask to the speaker. And now, before starting, I would like to check that all speakers are present, and I'd like to introduce them and ask them to quickly confirm their presence with a few words. So let me start by asking whether Mr. Kasper Jetzen, the head of new markets at Siemens Gamesa, is present.
Yes, I'm here.
Super. And then Federico Toscano, renewable energy public policy and market specialist at SBM Offshore.
Hello, I'm here, yeah.
Great. And Patrick Muller, CEO of Core Power Ocean.
Hi, Patrick. Yes, I'm here.
Hi, Patrick. Marlène Moutel, commercial engineer at Tabella.
Hi, good afternoon. I'm here.
Hi, Marlène. Bob Meyer, chairs of the implementation working group for offshore wind of the set plan.
Yes, hello. This is Bob Meyer. I'm present.
Hi, Bob. And last but not least, Cornelis Splatt, the project coordinator of the Horizon 2020 promotion project.
Yes, I'm here.
So we are all here, so I will not take any more time from this session, and I would like then to ask Mr. Kasper Jetzen to start with his interesting presentation.
Thank you very much, Michaela. Yes, so I represent Siemens Gamesa, and first of all, I also like to thank you for the invitation, and also that we from Siemens Gamesa find these initiatives extremely important and welcome them. I wanted to give you a bit of insights from an OEM perspective, so that is what I've planned here, and then end up with some of the challenges that we see and also some of the benefits from an OEM perspective. Next slide, please. So just as a glance here, I think I don't want to go into details here, but we are from Siemens Gamesa, one of the pioneers also within offshore, and we have installed 15 gigawatts out of the 22 gigawatts, I think, by end of last year. So we have been in industry from the very beginning. Let's please go for the next one. And also here you can see with the development of the turbine and also the wind farm sizes over the last 30 years. So we started with the very first offshore project in 1991, Vindeby in Denmark, which had a total capacity of around 5 megawatts in all, where we today have our 14 megawatts, which will be installed in the coming years. But you can also see the sheer size of the projects are developing here with 1.5 gigawatts for the HKZ in the Netherlands in 22. So it's a huge development that have been going on in the industry in the last 30 years, and especially the last 10 years have been quite impressive. Also from an innovation perspective of the turbine size. Next, please. Yeah, and also the cost have gone down quite dramatically over the last years. I think in the last 5 years we have seen a drop of 60%. For example, for the CFD and CFD3 in UK, we have seen a reduction of 30% over the last 2 years. So offshore as a whole is becoming a very competitive energy source, and especially in Northern Europe, it's on par with other energy forms. So from an industry perspective, that is of course extremely positive. Next, please. So Siemens Gamesa, we have a global footprint today. We have our, from an offshore perspective, we have our main factories here. As you can see in purple, we have Aalborg in Denmark producing blades since 2002. We have Cuxhaven in Germany, which started out in 2017, then Hull in 2016 doing blades, and then at the moment we are building nacelle assembly in Taichung in Taiwan, and also Le Havre in France, where we are also building a big factory for both nacelle and blades, which will start producing also in a couple of years' time. So I think we are investing quite a lot in the industry, and also the capacity is there from our point of view to support further growth of the industry. If you take the next one, please. So the core markets, of course, Europe is one of the core markets for us as a whole, but US, China, and other Asian markets are picking up in the last years. So we clearly see a global expansion of the offshore industry. I think one of the important parts here is that Europe, as well for onshore, it's also seen as one of the, let's say, the main stakeholders in the globalization of offshore. So that, of course, means from a technology perspective, innovation. The rest of the world are looking at Europe when it comes to that. But also from a capacity perspective, we of course are combining export out of Europe with local content initiatives in markets around the world. So going forward, Europe, from our perspective, are also seen as one of the would be one of the main export for green technologies from an offshore perspective, and I think that's very important. Yeah, go to the next one. So when we look into the challenges, I think also what we have heard today, so of course for us, for our perspective, long-term targets to support the industrial development, from our view, we need long-term sustainable targets and volume also to secure our investments that we do in the market. So we need predictable and stable volumes for the investments, also to be able to cater for the research and innovations and upscaling of production and energy transitions or in other technologies, and that we have invested quite a lot in the last years. We of course also see that the as we have heard today on the grid is a backbone of the implementation of the strategy, and we do concur to those things we have heard today. So missing grids is we have seen also, for example, in Germany over the last years, not so much of course the offshore grid, but the onshore grid is extremely important that we have plans, long-term plans, and we see also, of course, the European Commission to be one of the main stakeholders here to make sure that we have the plans and the development so we get the right maturity over the years from the grid perspective. And again, hybrid grids across country connections is also very important, and it brings up a lot of let's say other opportunities in hydrogen as well, floating and so on. So we definitely see the grid as one of the main challenges also going forward, where we need support and long-term plans to support the industry. And last but not least here, the maritime spatial planning, of course, as we have heard some good discussions before lunch today. I think we again can only second that it's important that we get started now, because it is a complex topic, and there is numerous of critical stakeholders that needs to be taken into consideration here, both from and balancing, let's say, climate protection and environmental protection. So we also want to support that, and that we get started right away with that, so we come up with, let's say, some feasible plans for the next decades to come. Yeah, last one I have here is some of the benefits, at least seen from our perspective. So as I said before, the home markets here, we are investing a lot in Europe, and also continuing doing that, as we show also with France as our latest investment. So that will of course secure also know-how and jobs in Europe. As I said before, also we can continue the green technology export that have been going on also with onshore and other technologies over the last years. We can continue that from an offshore perspective, and we are doing that as we speak. So I think that brings a lot of value also in the overall strategy for Europe in reaching the 450 gigawatt targets. Last but not least, I think also taking the current COVID-19 into consideration, we also strongly believe that we can actually, by investing in additional capacity for offshore wind, we are creating value to overcome the challenges we see, both supporting the green transition, but also the economies here in the current crisis we are in with COVID-19. Yes, I think that's more or less it for me. Thanks.
Thank you very much, Casper, for the very interesting presentation and the overview. I would like now to pass the floor to Federico Toscano from SBM Offshore. Federico, your 5 minutes presentation can start now.
Okay, thank you. So we can, thanks for the invitation. We can go directly to the next slide, please. I have privilege to be in a company which develops not only floating offshore wind, but also wave energy, and has quite some experience in offshore power at large. So I really try to have, to use this double hat to focus on a bigger picture, let's say. I know that a lot has been said on the climate and social impact that this offshore power transition and the ORE strategy can deliver. I think a key message is also the economic returns for the European Commission and in general nations which invest on these technologies. I think these 3 points are quite clear. The European Union has been in front seat as far as offshore renewable energies technologies development is concerned. This has been proven by bottom-fixed offshore wind, is proven by floating offshore wind with developments in America, Asia, etc. And is becoming more and more clear with ocean energies such as wave and tidal energy. So I think that the intellectual and knowledge leadership that the European Union holds strongly now should be capitalized, as well as the dynamic investment environment that has been created, and not only in terms of the risking of technologies. So by investing directly on technology and say, we believe in your technology and that your technology will take off, the European Commission has done a great service to technology developers. But first, mainly most importantly, also it has created a flourishing environment in which clients tap on our doors, saying, we see that the European Commission and national governments see a true potential in your technology. We believe that investing in your technology is the right thing to do. So why don't we set up a program together, and we take it from A to Z. We take it from the technology development perspective up to delivery to a project to a client, and that is thanks first and foremost of the policy implementations driven by the European Commission and national governments involved. And this has been translated consistently in a high rate of return on the investments from policymakers, which has translated not only in the social and climate impacts, but also in terms of jobs and business opportunities created and export. What I think is a bit more interesting, maybe from a floating offshore wind perspective, is that floating offshore wind, in the wide spectrum of energies, of offshore energies, from bottom fixed up to ocean energies, is for sure the next protagonist on stage as far as offshore renewable energies are concerned, and has specific features, which are the fact that it is diverse enough from bottom fixed offshore wind to be complementary to it and create synergies such that it helps in unlocking new geographical areas which were out of reach with bottom fixed offshore wind, but still is close enough to the technology so that we manage to capitalize on the achievements of offshore bottom fixed offshore wind. And I think the great possibility here is really to accelerate and to ensure by investing in this technology that floating offshore wind does not follow the same curve as bottom fixed offshore wind, but rather makes a giant leap directly right behind the bottom fixed technology in terms of cost competitiveness and size of turbines, etc. The next slide, please. So after why, how can we deliver it? And I think that it applies very well to floating wind, but also to wave energy and ocean energies in general. The first point, and I think that's a point expressed by all the participants, is that we should continuously support technology from A to Z, from fundamental research up to demonstration. Innovation is a continuous process, so even if we manage to provide a cost competitive and reliable product, this does not mean that we cannot do the work better, or in terms of floating wind, going farther in the sea or deeper in the ocean. And we should ensure also that not only infrastructures follow. This has been partially done by bottom fixed offshore wind with the creation of the infrastructure, the enhancement of the existing infrastructures, ports and grids in particular, but also with the stimulus given to alternatives to grid. For example, power to X, being it hydrogen, ammonia, power storage, but also access to other sectors such as aquaculture or other offshore industries. Please, next. So to rapidly conclude, I think the last point we should not miss also is that offshore renewable energy has a marginal advantage, which is incredibly important, and which is the fact that offshore power already exists, and in the terms also of offshore oil and gas, green transition is there, and it's the aim of everybody to deliver it. Still, we have to acknowledge and capitalize on the century of cumulative experience of operation of offshore offshore oil and gas, to ensure that offshore renewable energies speed up and are boosted by this knowledge in terms of safety, but also in terms of technology developer, so that we manage to do a smooth transition, but still doing it in accelerated mode, providing sustainable and very safe energy from the oceans. So that's all for me. Thank you.
Thank you very much, Federico, and thank you also for sticking religiously to your time. So I now pass the floor to Patrick Möller from Core Power Oceans for his 5 minutes presentation.
Thank you very much. Thanks for inviting us. So Core Power, we are a developer of a new type of high efficiency wave energy converters. And today I want to speak about how this can enable the transition to 100% renewables and what we need and continue to support from Europe to get there. Next slide, please. And wave energy, it's a huge opportunity really out there. We're talking about 500 gigawatts of commercial deployment potential, about 10% of the global electricity, also about 10% of European electricity. So a big opportunity for carbon dioxide reduction of between 1 and 2 gigatons per year. And what really makes wave energy interesting is that it is a much more consistent production profile compared to wind and solar, which is complementary, meaning you can fill out the gaps in the days when it's not windy and not sunny. And by that, wave energy can provide natural grid balancing when we see increasing penetration of wind and solar. Next, please. So here's an example of a typical production curve between PV, wind, and wave. This specific example is from 1 week of simulated production in California, but really the curves are equivalent in Europe. And what you can see is that wave energy is much more of a flat curve. On the short time horizons of days to a week, it's much closer to a firm source than an intermittent source than wind and solar. And what this offers is an opportunity here for our customers who build wave farms to offer a much higher value product into the market. We've seen today already in markets getting to high penetration of wind and solar that in a windy day, for instance, you see very low electricity prices, sometimes negative. And then when there is too little supply to match demand, you all by a sudden say high price spikes. And that level of volatility we can only expect to increase when the level of intermittent renewables is increasing in our grids. And this is really the key role we see for wave energy and tidal energy to fill out those gaps. Next, please. We see several of the big developers who are currently developing projects based on our technology is looking at the chance of combining wave arrays with floating wind arrays offshore. That gives you an opportunity to combine the electricity into the same cable to get a more consistent output, sell electricity with less variability to the grid, and also to, of course, reuse CapEx investments, project development investments, and so on, and get to a lower cost of electricity. Next, please. So in Core Power, we have developed a new type of high efficiency wave energy converters. As you might have known, a challenge with wave energy in the past has been that either devices have broken in storms or they've just not produced enough compared to their size, weight, and cost to make it a viable business case. This is something that has really changed in the last years, and with the newest generation of devices, the metrics become extremely competitive in the markets. Next, please. And what we have introduced in Core Power is an ability to be transparent in storms, and by that surviving the toughest weathers, at the same time strongly amplifying the absorption in regular waves. So in average, we get 5 times much annual energy compared to the weight or the size of equipment you need to install in the ocean. And that really brings down the capex, and getting a large amount of energy out from a small low-cost device also makes it possible to transport, install, and service these devices using low-cost vessels. That brings down the OPEX. And together, that contributes to a really competitive cost of electricity. We get a fairly quick curve to get down to the 30 euro per megawatt hour level. And together with the grid balancing aspect, making each megawatt hour more valuable in the market, that's a very compelling proposition for the customers building arrays with wave energy devices. Next one, thanks. So we've been proving this physics and the economics in a step-by-step approach since 2012. We're currently in our first demonstration of our first full-scale device that we call Stage 4. And we are dry testing a device in Sweden this year and then installing it in Portugal next year. After that, this will be followed in Stage 5 by a first pilot array with 3 more full-scale devices. And by that, we aim to achieve type certification and certification of performance, yield, and availability, so that we can give warranties to our customers, and then to have a bankable product by the beginning of 2024 to start shipping in volume to commercial arrays. Next one. So what we need right now is really the support from the European level. We are extremely thankful for the support we have seen through the early stages of R&D and scale testing. Now we're bringing this to full scale and array demonstration. We have a budget here of 55 million euros for our Highway 5 program, which means demonstrating this first single device full scale and then 3 more full scale devices. And we would need about 25 million euros of grant support to be combined with private investments to take that all the way to bankable product in the market. Next one. And as a European taxpayer, what you get for that is the demonstration of a fully compliant wave energy array to achieve type certification, which we're demonstrating in Agusadora in northern Portugal. So next year, we're going to install a first C4 WEC that we call the single device there, collect that to a collection hub, and get 1 cycle of learning in that demonstration and then in 2023, add more 3 devices onto this array, making it 4 device array. We're using the same substation and the cable that was used by Windfloat for the Windfloat 1 demonstration. And Kopar, we're currently investing in a on-land R&D and fabrication facility for wave energy devices in Viana do Castelo in northern Portugal. Next one, please. And really then from 2024, when we have reached a bankable product with type certification and warranties, what we need then is for our customers to have some level of support to drive the volume deployment that drives down the cost. In the very first arrays in 2025, we might talk about 25 euros per megawatt hour in LCOE, but quickly that comes down. And in 2028, after having deployed 300 megawatt, we expect to be below 100 euros. In 2030, after having deployed 600 megawatt, we expect to be below 65 euros. And then we see the path to 40 and down to 30 when we step it to 2040 and 2050. So our deployment plan, our business plan is based on having about 29 gigawatts deployed here by 2050 on a global level, but a big portion of that in Europe. But in order to drive that in the early days from 2025 till 2030, when we reach the 65 euro, next slide, please. The help we need there, it's to have CapEx and OpEx support to our customers of the early arrays in similar setups at the Innovation Fund. We think that's an amazing initiative taken. And from national countries and possibly Europe, if possible, to combine that with some revenue support. To drive all the arrays that our customers are developing to get the 600 megawatts into the water, you end up about 30 million euros of revenue support per year in 2030. And that's the level we need in total to take this to a fully competitive product in the market. Next one, please.
I need to ask you to conclude the presentation. Yes. I'm really sorry. I see the passion.
This is the last slide. But this is a massive opportunity. So we're talking about 400,000 European jobs by 2050 by wave energy, and really a big opportunity for European leadership. We are in the lead, and with this help, we can continue to stay in the lead. Thanks.
Sorry, can you hear me?
Yes, I can hear you fine.
Yes, yeah. Okay, sorry, I was speaking by myself. Thank you very much for the very interesting presentation. I now pass the word to Marlène Moutel from Sabella.
So I'm going to take you from wave and offshore wind to tidal energy. So my name is Marlène Moutel and I work for Sabella as a business developer. This presentation will give you an overview of what we are doing at Sabella and the device that we are currently developing and at which stage we are today. I will also take you through the different demonstration projects that we have in France and the one that we have in the pipe in France and overseas. Next slide, please. So Sabela is a company based in France, created in 2008. We are currently 25 employees working in Brittany, and we are still hiring despite the COVID situation, which is, I think you're...
Probably. I will try to take, okay, perfect. Thank you very much. So yeah, 25 employees based in Brittany in France. We are still hiring. We just got 2 new people coming in during the COVID situation, and we plan to be up to 35 in the years to come, approximately in 2025, with all the projects that we have in the pipe. We are an EPCI company, meaning that we are doing the engineering, the procurement, the construction, and the installation of tidal stream turbines, just like the one that you can see on the pictures. We are investing a lot of money into R&D projects. We do have, I think, almost like 10 R&D projects under development now, and probably as much that have been over now. So circa 3 million euros of investments. We do have 5 tidal arrays projects under development, some of which I can speak about and some of which I'm not allowed to. But we do have 2 tidal small pilot arrays under development in France, and also 1 in the Philippines and 1 in Canada. Next slide, please. Oh, so can you try to click one more time? This is supposed to be a video. Oh, no, come back. Yeah, so I'm sorry, we do not have much video of the device underwater because it's 50 meters deep, which is not really easy to access due to the high current that we can see on the side. But this is supposed to be a video of the turbine spinning, but now it's fixed. But I'm happy to share video if you want me to. So the main demonstration project that we have with our technology was a project deployed in USHANT Island. USHANT Island is a small island off the Brittany coast, which is the home of approximately 900 inhabitants, and it's an off-grid area, meaning that you don't have an underwater export cable between USHANT Island and the French European interconnected network. So the island is now currently only relying on 100% of diesel power production, which is absolutely polluting, noisy, and not the most friendly solution for the environment. And just next to this island, you have a huge amount of current velocity. And so this is the place we have chosen to develop our 1 megawatt device, which has a 10-meter rotor diameter. So quite a first of its kind project, the first, in fact, tidal turbine to have delivered energy to the grid, to the French grid, sorry. So we did operate and monitor the turbine for our 12 months authorized period between 2015 and 2016. So huge amount of things to learn on how to operate into this harsh environment, and also to inject into a really fragile grid, which is the off-grid of USHANT. Next slide, please. So today, as we know that tidal stream energy is currently in maturing process, and that the technology is still quite expensive compared to what you can find into the interconnected grid. We are focusing on remote and off-grid areas that have a clear need for a cleaner source of energy, and where the current electricity production is really expensive. So we did another demonstration with the same devices of 1 megawatt into the same location to learn more on how to verify all the mechanical integrity, the electrical signal of the device, and also optimize our environmental monitoring. So currently the device is in maintenance in Brestport. We did have some delay due to the COVID-19, but it's supposed to get back into the water in summer 2020, late summer. And it will be in the water up until 2023. Next slide, please. So Sabela, with our tidal device development, is currently
J'en ai marre de cette saloperie.
In the pre-commercial stage. So we did deploy full-scale devices which have been operating in relevant operational sea condition in USHANT Island, which is one of the sites with the most powerful currents in Europe. And we are now developing and in the engineering process of our pre-commercial small arrays of 2 to 4 devices that will be deployed also in an operational sea condition. So we are benefiting from R&I grant funding. We also have funding for the development of those small arrays within both national and European funding. But the next step between pre-commercial and industrial rollout is quite blurry now. And there is still a clear need for our TIDAL company to benefit from public support and private support to be able to move forward to what we are currently sitting now, which is the most known valley of death. Next slide, please. So for the challenges in the tidal energy sector, so as you all know, this is a nascent industry. We only have a few number of devices that have been operated for a few years now, approximately. We do have, like, I think it's 18 months of cumulative energy production into the water. So we are currently building our track record, which is really needed to get the confidence of investors, but also project developers that we are working with. And there is also a lot of work to do regarding the reliability of the device, which is like the core point of bottom fixed tidal development, as we don't want to get the device out of the water every year, because that's what costs the most money in the project. And so we are really going down the learning curves. All of the new innovation that we have under development will help us to go through that. We're also learning a lot into the marine operation, which is, like, as I was saying, a key point to work on as we're walking into harsh environments where the logistic is just like really complex. And last but not least, we are also working on the design of the tidal technologies to optimize the power production and also improve the reliability. Next slide, please. In terms of financing, so I think that has been said a lot of time already, but public funding is really essential to be able to get private investments. We see that every day, and that's really something that must be worked on. Also, for the first pilot project, we really need to now work on the reduction of the cost of capital. As the project we are working on today are still really risky and have a long-term gestation period, it's impossible to get access to commercial bank and institutional investors to secure debt financing, which is costing a lot in the full business plan. Also, of course, decrease the risk, I said that already. And the last point I want to speak about was the insurance market, which is today highly tense, and it is something really needed for us to work on to be able to get our project insured on the long term. And this is also a high cost for the project when you look at the long term operational costs. And so all the funding, the grant funding, the real estate deployment funding, and the different financial instruments, including revenue support, will help us to go out of the valley of death and get access to an easier funding. Next slide, please. I think that's the last. Thank you very much for your attention.
Thank you very much, Marlène. And that was a really, really interesting overview on your work. And I would like now to pass the floor to Bob Meyer, the chair of the Implementation Working Group for Offshore Wind, who can give us his 5 minutes overview.
Well, thank you for the introduction and the opportunity to say a few words about the Implementation Working Group activities for the SET plan. For those of you who are not familiar with the SET plan, this is a European plan for strategic energy technology development, basically to improve technologies, but also to bring the cost down. And that plan works across member states in collaboration between industry and research institutes. Next slide, please. So a lot has been already said about the energy transition, and of course fulfilling the obligations under the Paris Climate Agreement means a worldwide transformation. Every region in the world has its own specific energy resources, renewable energy resources, be it wind, solar, tidal, wave, etc. Now in Europe, we're blessed with very good resources if it comes to wind, both onshore and offshore. And the IEA report on offshore wind in 2019 looked at the situation in 2040. And in the graph on this slide, you can see that what the technical potential of offshore wind can be. So 100% is then the electricity consumption in 2050. So we're blessed with this enormous resource for offshore wind. But also you can see that it's globally there's a lot of potential. And I think at the moment we're in Europe at the say a very good position. Basically, it's a perfect storm of an industry that is rapidly growing, where Europe has a very strong industrial leadership position. We have got our own resources, but also worldwide, the projections look very good. Now, to capitalize, next slide, please. To capitalize on that leading position, we need to have a look at a couple of challenges that we face. On this graphic from Wind Europe, the vision for 2050 is set out of 450 gigawatts of offshore wind. This is largely bottom fixed offshore wind, but also potentially between 100 and 150 gigawatts of floating offshore wind. Now, the challenges we face, if we are really want to make this ambition true, we have to look at further cost reduction. And in the earlier presentations, also by Casper from Siemens Gamesa, we've seen that the steep decrease in generation cost of offshore wind already, but we're not there yet. And if we really want to electrify our society, be it mobility, our industry and households, prices must come down even further to make that happen. Also, if you look at the vast amount of electric power that we have to bring on shore, we can no longer do this basically based on electric connections only. So we're looking at also system integration aspects of, for example, converting electric energy offshore to other energy carriers like hydrogen. But also the onshore grid integration is a very important element. And a third point I'd like to mention, that was also discussed earlier in the previous session this morning, has to deal with, say, the other uses of the sea and also the ecological impact. So from a spatial planning perspective, a lot of hurdles need to be taken to make this all happen. And the good news is that research and innovation can actually address these challenges. And the set plan for offshore wind targets to address these challenges. And it targets these challenges with research in various research areas. I already mentioned system integration, but also looking, for example, at the balance of plant, installation, transport and installation of offshore wind components, development of wind turbines and further research in that area, and floating offshore wind, of course, and trying to bring the cost further down, but also the operations and maintenance side of offshore wind. Also, if you look at the industrialization, if we are envisaging such a very fast and high growth, industrialization is also a very important innovation area. It was also mentioned before by Federico from SBM that research is required from fundamental to demonstration. And also some basic wind energy science need to be addressed further. So the good news is that there is an enormous opportunity there. We're in the perfect storm of a high growth market with a leading position in Europe. And if you can come to the next slide. So we have this resource. We also have the infrastructure, looking, for example, at the existing grid infrastructure, but also at ports and everything that we need in this area. We have the knowledge and a leading industry position, and research and innovation can make this growth really happen further. and it provides an opportunity to extend our global leadership in this area. And that concludes my presentation. Thank you.
Thank you very much, Bob. This is a very good overview on the work of the SET plan in this area. I now pass the floor to Cornelis Blett, our final speaker from the promotion project.
Yes.
Cornelis, your floor is yours for the next 5 minutes.
Okay. Yeah, thank you for the opportunity to present here. I'm a consultant with DNV-GL and also coordinator of the promotion project, which, as you can see, stands for Progress on Meshed HVDC Offshore Transmission Networks. We are a EU-funded research project. We have 34 partners from 11 different countries in Europe, and we are almost at the end of our project. And I'd like to tell you a little bit what we are about, what we have done, and share 3 key outcomes of that. But before I do that, I'd like to give a little bit of context. Could you go to the next slide, please? So what you see here is, of course, a map of the North Sea. And as we've understood already from the previous presentations, this really is the arena in which part of the fight for meeting the Paris climate targets will be fought by, for example, offshore wind or other forms of offshore generation. This is where we will meet hopefully 200 gigawatts of offshore wind generation target. On top of that, this will be the area where we will realize a large part of interconnection target between different countries, so that these different forms of energy can be traded and shared between different North Sea states. And we have a vision that all of this transmission capacity, for as far as it's done electrically, is done in a multi-terminal cross-border HVDC network. HVDC is a technology you need to use when you go far offshore and you need to transport large amounts of power by cable. And this grid needs to be, of course, growing organically in a stepwise fashion, because we cannot afford to have a centrally planned grid. It should also combine all the different purposes for such a grid in one transmission infrastructure. These different purposes are, for example, the export of generated energy, but also the interconnection of countries, the supply of offshore consumers like oil and gas platforms, or reinforcements of onshore AC grids. And ideally, this is also built not just by one party, but by different vendors, and perhaps even owned and operated by different organizations. Now, this is not what is happening today. What you can see here is a map with all of the existing and planned HVDC links in the North Sea. These are all point-to-point links with one owner, with one purpose, crossing no more than one border typically. And this is what we are hoping to change in promotion. What do we need to achieve? What do we need? What kind of technology do we need in order to enable an interconnected grid to develop? And what do we need to change in forms of regulations in order to incentivize the development of such a grid? Next slide, please. So we have developed the strategies and the technology to operate and protect such a grid to realize reliable operation. We've looked at how we can achieve interoperability between different technologies to allow this stepwise organic development. We've carried out a gap analysis on the regulatory and financial frameworks in the different countries around the North Sea to see what the differences are and what kind of patches or improvements we could suggest in order to overcome those differences and create a level playing field. Finally, we've put all of these actions into a deployment plan in order to see what do we need to do today in order to really reach this 200 gigawatt goal by 2050. And finally, maybe most importantly, we have shown that the technology is in principle ready to go. Next slide, please. So we have looked at the 4 key technology elements for realizing such an HVDC grid, which is HVDC grid control, protection, HVDC circuit breakers, which you need to clear faults in the grid, and HVDC gas insulated substations, which you need to build substations in a very compact way. And by testing these at full scale and full functionality, we've shown that in principle, this technology is ready for commercial and industrial rollout. So the puzzle pieces are there. Next slide, please. The only problem is that we need somebody to put this puzzle together. And this really requires coordination and standardization on all stakeholder levels, right from the political agreement to actually want to build such a grid between different countries, all the way through technical requirements and even contractual compatibility between how different grid extensions are procured. These could be finalized in instruments such as North Sea treaties, all the way down to standards or recommended practices, and have various stakeholders from international bodies down to standardization bodies involved. Next slide, please. We believe that the best way to show that it is indeed possible to implement such a grid and to coordinate and standardize is to do this also in a stepwise approach by building up the complexity and the risk associated with implementing these new technologies and new regulatory approaches in increasing complexity. So starting with what we have already as point-to-point links that you can see on the left, adding more terminals to this, adding terminals with different technologies, having different vendors, making it also cross-border until you finally arrive at the sort of HVDC hub structure where different parties, different purposes, different terminals are reaching across different borders. If you'd like to find out more about the actual recommendations and the results from the demonstrations, please come to our online promotion conference, which will be from August until September 18th in 5 different sessions, covering the different technical, regulatory, legal, economic, and financial topics. Thank you for your attention.
Thank you very much, Cornelis. And now I would like to move on to the question and answer session. So as it happens in this case, when we have so many excellent presentations, even in this case, we are running a bit late. So I'm going to ask just one question for each of our presenters. And I ask them also to be a bit brief if possible, and then hopefully there will be more chances to answer any additional questions that might come up from the chat. So let me start with the first question. The first question is for Casper Jensen. So what is the impact on the employment in Europe of the development of Siemens activity in Asia?
Sorry, come again. The connection is not good for me here. What? Sorry.
Sorry, could you hear me? Can you hear me now?
Yeah. Yes, sorry.
Okay, let me repeat then. So what is the impact of the employment in Europe of the development of Siemens activity in Asia?
Well, that's a good question. I think what I also stated in the presentation was that we see a combination, of course, also from a cost competitiveness for our clients, also that we are producing different components in Europe and also setting up different components for be produced in Asia. So we are trying to, let's say, combine the best of both regions. So there are also long term, there will be a need for capacity in Europe to support in Asia, for example, or US for that matter.
Thank you very much. Now I see here that we have a question for Federico Toscano. So Federico, here our audience is asking us, so what do you see as the key core challenges in offshore floating wind power when it comes to levelized cost of energy, which is quickly catching up on the sorry, I'm just rereading this, it's not written very well. So what do you see as the key challenges in offshore floating wind power, LCOE quickly catching up to the bottom fixed?
Well, I think that there's no core challenge in terms of technology. Technology, I think we all agree that has been de-risked at a sufficient level as to provide certainty on the cost out path. I think it now needs is action actually. So really deploying projects, deploying prototypes or demonstration, and let the industrialization do its path. I think that's will be the easiest way to drive costs down. But of course, if we really want to take all technology as to drive LCOE further down, I think one of the topics should be mooring legs, and I think that's an important one. But I think for the time being, the most important path is really driven by industrialization.
So our next questions to Patrick Müller. Where are located in Europe the main resources for wave energy?
Well, the key markets here and the key opportunities is along the Atlantic arc. So starting from south, we're talking about Portugal, Spain, France, and then going up to Cornwall, Ireland, Scotland, and Norway. These are really the key markets, and this is where you find the best wave resources, but it's also where you find the big swells. Since you have the global oceans or the big oceans there with the Atlantic, where you've had weather systems that have worked up the waves for several days, these are the places where you get the best complementarity between wave energy and wind, for instance. You have a very low correlation between the sources, and because of that, the biggest value to the electricity systems. Thanks.
Thank you very much. Very interesting. So, Marlène, now it's for you. What is today the main challenge from tidal stream energy takeoff in Europe? Is it technology maturity? Is it financing, permitting? And what could be done at European level to support this development?
So yeah, I think this is like kind of a mix between the technology maturity, which is currently under development. So there is still a few lack of return on experience regarding, for example, reliability and performance, which can still be improved and optimized, probably thanks to research in innovation grants and funding. The second point could probably be financing of the projects, because you are moving from demonstration project, like small unique device demonstration project, to small pilot areas with multiple devices. So this step is probably one of the most difficult to go over, because you are talking about much more investment at the beginning of the project. And so the match funding of the project is much difficult to secure. So of course, yeah, I think that the best solution could probably be research and innovation grant funding to support the optimization of the technology and the improvement of its reliability. And the second point would be funding to support the development of those small pilot areas that will allow you to learn a lot, both on technology and also on the interaction between the devices within their environments.
Thank you, Marlène. Now we have a question for Bob. Bob, from your perspective, what is today the main challenge that RNI activities could help to overcome when it comes to triggering a massive deployment of offshore renewable energy in Europe?
So that's offshore renewable energy in general, not specifically for offshore wind.
Well, you can start with wind, but if you have also, let's say, an opinion on the rest.
Yeah, okay. I think it is not so much there is one dominating challenge. I think it's a combination of all the three I mentioned. And so if costs come down further, then the market potential for massive electrification based on offshore renewables is huge. But if the costs don't come down, then of course that market uptake will be less. And the industry, the European industry, can only afford so much to pay, for example, for the production of green hydrogen. And the numbers that we've seen from the industry in terms of, say, their cost target for renewable electricity are extremely low. So I think that's an important aspect. But once these volumes start developing in the vision also of Wind Europe, then we're looking at these other areas, like how to integrate this massive amount of electricity in our energy system. And also how we can cater for sufficient space, also the interaction with other users, even to facilitate other users of the sea. and also to make sure that we still have a positive contribution to the ecology. It's these three challenges: cost, system integration, and spatial planning aspects go hand in hand.
Thank you very much, Bob. Our final question is for Cornelis. So Cornelis, from your perspective, do you think the EU should enforce regulation on standardization and interoperability?
Yes, although that is not the only thing, of course. Having a minimum set of technical parameters that is agreed between all of the participants in such an offshore grid is a necessity. Otherwise, a development, like an organic stepwise development of such a grid, is impossible. And therefore, things like, for example, system operation guidelines, which are also EU legislation, and grid codes for the DC system, so not the interface to the AC grid, but the DC side itself, they currently don't exist and need to be developed. And the EU is definitely the stakeholder that can push for development of this type of legislation. Apart from that, there are also many other things that need to be initiated and probably pushed by the EU in order to make this happen. Maybe the most important one is to centralize the spatial planning use of the North Sea, with a view, of course, of how this would shape the electrical infrastructure that needs to come there, in order to be able to combine all of these different purposes and find out what grid extensions make sense from a business case point of view. And that sort of process, which today exists somewhat in the 10-year network development plan, should, in our opinion, be expanded in order to include the different purposes and to include a view to an integrated offshore HVDC grid.
Thank you very much, Cornelis, and thank you everybody, to all the speakers, for your incredible presentation and for this lively question and answer session. I now have to pass the word to the floor to my colleague for the next section, but really thank you again for this, and I hope we can make then available the presentations, because they were particularly interesting. And I'll pass the floor then to my colleague Thomas for the next session. Sorry for having stolen a bit more time than we wanted to, and thank you very much again.
I will. Hello, can you hear me?
Yes.
Yes, can you hear me?
Yes, Thomas, we can.
Hello? Okay, sorry, I had to change my device. So thanks a lot, Michaela. So I'm taking over for this last session of the webinar. Thank you for having followed the whole discussions up to now, and we have now a big half an hour to dedicate to the last issue, but clearly not the least for this webinar. We will then concentrate our attention now on another dimension of offshore winds, as we already said a number of times during this the discussion, that offshore energy will be clearly a vector of sustainable growth for the EU in the coming years. But it will also be a vector of inclusive growth in sense that it will it's expected to contribute to a growth which is fairly distributed across the EU in terms of territories. So, of course, coastal regions will be the first concerned, and we see that there are regions with more experience already in the field, but this should be beneficial to all starting from sea basins, then all the regions which are linked to the different sea basins, Black Sea, Mediterranean Sea, Atlantic, and of course then the more experienced North Sea and Baltic Seas. This is an element we will consider in this session, and another one which is also very important, related to the human capacity. If we want to achieve the ambitions we have in terms of development and sustainable development of this type of energy capacity in the coming years, we'll need to have the humans and the work pool behind it to really lead this new activity. And here comes, of course, the question of having the properly set education system to ensure that we have the skills available at the right place and at the right time for the development of either the technology as a whole at European level, but also ensuring that it is implemented and run at a very local level when it's about, for instance, maintaining and running some offshore energy farms. So this is in a nutshell the elements we will consider for this last session. Before introducing the speakers, I have, even though I think we are now experienced, but I have to repeat again that we invite all the participants to remain muted and not to have any camera running to preserve the bandwidth. If you have any questions, of course, you can do as it was done so far. You can address your questions to the speakers via the moderator. So you have to flag when you use the chat that you are addressing your question to moderator, and he will pass the question to me, and I will then relay it to the extent possible due to time and maybe quantity when the Q&A session will start. I will now quickly introduce the speakers and I will ask them to confirm that they are well online, not to experience what I just experienced now. So we have, as a first speaker, we'll have Mr. Jep Janssens from the Clean Energy for EU Island Secretariat. Are you online?
Yes, I am. I wonder if you can hear me.
Okay.
Do you hear me?
Yes, we hear you very well. Yeah.
Excellent.
I hear you. Then we'll have Jose Horsmacher from the Basque Energy Cluster. Can you hear us?
Yes, hello. Good afternoon.
Okay, hello. Then we'll have Mr. Brook from the Conference of Peripheral Maritime Regions.
Hello, I hope you can hear me.
Yes.
Great.
Very well. So everything is fine on this side. And we'll have Rémi Gruet from Ocean Energy Europe.
Yes, good afternoon, Thomas.
Can you hear us?
Yeah, I can hear you. Can you hear me?
Okay, perfect. Yes, we hear you perfectly. And we will end the session by Mr. Frank Gilland from Inno Energy. Can you hear us?
Yes, I can hear you. Yes, we can hear you.
Very good. Okay. Okay, very good. So we can start. I give you the floor, Mr. Jensen. Please, you can start your presentation.
Thank you very much, and I believe that I will tell you when we need to change slides, right?
Yes.
Okay, and you may already do that because you've heard my name and you know where I'm from. I will give you a very, very brief introduction to the Clean Energy for EU Islands initiative, because it touches upon a lot of the things you mentioned already, Thomas, on anchoring and ownership, in particular, actually, and very relevant to today's theme, because the islands, to a large extent, will very often either they are already neighbors to, or they will become neighbors to offshore renewables in the future. And some of the things we are working with in the Clean Energy for EU Island initiative is to make it a joint effort for the energy transition on islands that obviously also includes renewables deployments off the shores. So just a very brief background, because this is not something that is taken out of thin air. Basically, you can see the member states here in 2017, all the island member states of the Union gathered and agreed on the fact that action was needed in order to provide specific support to the islands, both because they're due to their insularity and specific challenges thereof, but also because islands can, to a large extent, represent good examples of decarbonized energy systems that we, in small scale, that we can then see how society eventually will have to look like in the future. So these were some of the thoughts that were had back then, and today the Clean Energy for EU Islands Secretariat is working actively in this process together with islands. Next slide, please. And you can see here's just a map of some of the islands we're working with. Obviously, you cannot see where these arrows are pointing. So this is a subtle invitation to go and visit our website, euislands.eu. You see here that our approach is a bottom-up approach that is combining transition management with the quadruple helix approach in order to ensure that we get a good ownership of the energy transition, and also to realize, based on the realization that we all have to make an effort in the energy transition. So everybody, this is not only sort of the public sector's challenge. We all need to take our part in this. And here, islands are also a specific case due to their insularity and their often very tight communities. This is, we see extraordinary results of this collaboration across the helix here. Next slide, please. I'm jumping very briefly here, but here I just wanted to show you a couple of examples of how we are trying to mainstream this transition, the transition management in a very simple way. Basically, the core of this is dialogue across opinions, because an energy transition in general requires a change of business as usual. Change of business as usual requires that some are moving out of their comfort zone, and that can sometimes create challenges. The most important thing is that these challenges are found. They are seen and they are debated, and basically the vision, a joint vision, will have to be created here in order to also show us, but what comes after our business as usual. And by doing so, everybody will be much more comfortable with the future and the whole transition process. So what we have created is a methodology that is basically creating that sort of fostering this dialogue to create a joint vision for the future. Basically, a full decarbonization of your island before 2050. And I will not go into details because we don't have time for this. But I think it. But I'll just ask you to take the next slide, because I'll just give you a brief snippet on what we call the Clean Energy Transition Agenda, because this is exactly the sort of the way to develop the vision. This is just a chapter. So please, next slide. And you see here, many of you have seen these types of circles before, but perhaps not this shape as you may call it a ping pong bat. Because the handle of this ping pong bat is actually the essence of the Clean Energy Transition Agenda. I've taken this snapshot out of a transition handbook, which I really invite you go and explore further. But here you can see that what we are after is the different organizations on the island to make a common vision with different pathways to take, so that when it comes to the development, sort of the first the feasibility studies and the yield assessments, and at the end of the day, the final deployment of renewable energy sources or energy efficiency measures, it is within the same vision of everybody. Everybody shares the same vision, meaning that nobody will be surprised, because it's very often that, I mean, we see it everywhere. The NIMBY effect is very often caused by surprises and lack of participation in the process. So there we're putting, we have been focusing considerably amount of our resource and capacity building on this first joint visioning. You would see there are several other projects and initiatives that are dealing with the other parts of this, let's say, energy planning cycle. You see, for instance, on the decarbonization planning, I guess one of the most well-known is the Covenant of Mayors. And you would see that the two initiatives here go hand in hand. So there are there's a broad palette of support initiatives and projects around this circle. So we are basically preparing the island somehow to enter this circle with a joint vision. Can I ask you for the next slide, please? So you see here are some of the goals set forth as the very, let's say, in the handle of the table tennis bat, in order to avoid any surprises, and at the same time, by including several different representatives on the island with different aspects, to make this kind of musketeer oath, kind of to work together on a common vision. You would also see that there is already a sort of a consolidating structure, so that, let's say, if it was the tourist association that had the green dream on their own, they may be more prone to put this in the drawer if, let's say, if challenges arise, than if the tourist association has made this plan together with the local business association and the municipal board, for instance. So next slide, please. So this is basically the sort of the core of the processes that the islands that are pledging to the Clean Energy for EU Islands initiative is going through. Here's just sort of a visual of basically it shows the discussions that are so important to have before you start sort of the more concrete action plan. And you'll see here it's the definition of different pathways, because I mean the future is difficult to predict one-to-one. So it's good to sort of consider different pathways, and in case the situation changes, it will not be a complete surprise to everybody, and at the same time, that will let people still feel comfortable with going towards the vision. Next slide, please. Which is just a series of pictures from some of the different activities going on. You will see the island of Colatra in Portugal. If you come to the island, the first thing you will see is this information. Actually, an old sail that has made that you can see our logos in the top. It's something that the island have made themselves. And the local Portuguese, in particular the fishermen there, are slowly learning English due to the English information that's put on this sail that is explaining Colatra's decarbonization vision. And that was my last slide. I have some contacts in the end, if you can, the last bit. That was incredibly quick, but I welcome everybody to go in and also join the community, because we need a lot of brains and goodwill and ideas to push forward this the transition of islands. Thank you.
Thanks a lot, Tiep, for having stick to the time, and we will still have the opportunity at the end of this session for some questions from the audience, if any. I will now give the floor to Jose Ormacher, sorry for the pronunciation if not done properly, from the Basque Energy Cluster.
Yes, hello. Good afternoon. Thank you for the opportunity. I will describe you a little bit about the value of the offshore wind future for the Basque Country, for the regional industrial fabric. Next slide, please. A brief introduction on who we are. I represent the Basque Energy Cluster. This is a cluster association for the energy companies in the Basque Country. Probably you know, a region, a very industrial region in the north coast of Spain. More than 20% of our GDP comes from industry, so that's one of our main, let's say, features as an economy. In the cluster, currently we have around 170 members, businesses, most of them, more than 60% SMEs, including companies and research entities and public bodies from all over the energy value chains. So that means we don't only have energy sector operators, companies generating or distributing energy, but also manufacturers of equipment, service providers, engineering firms, and of course, research entities and universities. Our mission, as most of the regional clusters in Europe, is to improve the competitiveness of in this case, of the energy sector in our region, very much focused on SMEs and cooperation, collaboration, public-private partnerships is one of our key issues. I mean, the main way we have to improve this competitiveness is through collaboration. We are quite active in the fields of technology, international promotion, and also in talent development for the companies and the sectors with which we are working. Next slide. You can see there the 6 value chains in which we are focusing the activities and the collaboration opportunities for our companies. On the left side of the slide, you can see that 3 of the most relevant value chains have to do with renewable generation, wind power, solar energy, and wave power. Wave power, a very emergent market, but we hope with a promising long-term future. Smart grids is also one of our key value chains and energy services for the consumers. And in our country, we also have a relevant group of companies delivering products, delivering services for the oil and gas sector. I will mention a little bit afterwards something about the companies coming from this oil and gas value chain. All of these groups of companies, all of these sectors are supported by key enabling technologies that you can see there are some of the most relevant we have identified with the support of research centers and universities working very closely. And that's one of our missions, to make them work as closely as possible with the industry in our region. Next slide. Next slide, please. In wind energy, yes. In wind energy, our region is especially rich, I would say, in terms of the number of companies that are actively providing, delivering products in the different segments of the wind value chain. In the last years, I would say in the last 4 or 5 years, we have increased the presence of companies in the offshore wind value chain. We foresee it's going to be one of the added value market segments for the wind energy market. That's why many companies that started many years ago working for the onshore wind farms are now evolving, are now developing solutions for the more demanding, more aggressive, let's say, offshore environment. But we are also trying to attract, from the regional point of view, to this offshore wind value chain companies coming from other sectors. I would say that we are trying to diversify the products and the activities of companies that, for instance, are presently working in the oil and gas value chain, companies coming from the shipbuilding industry, even in some cases, companies from the aerospace sector that are trying to adapt and trying to develop technologies based on their previous know-how that could be suitable, that could be competitive in the offshore wind sector. You can see there then the different segments, the number of companies with which we are working, and we have highlighted, you see there a specific segment that has to do with towers, foundations, and specific devices for the offshore wind floating platforms, in which we are also focusing a lot of effort and trying to push collaboration and projects. Next slide, please. You see there we have extracted or selected this segment of that offshore wind value chain. Most of the companies there, I would say that are companies coming from, as I mentioned before, oil and gas value chain, companies coming from shipbuilding industry, aerospace, even engineering firms coming from the civil engineering activities, are focusing their efforts and their know-how in this promising sector. That's why we have grown a number of companies that have developed their own concepts for floating platforms. In this sense, we are very actively engaging with regions and partners all over Europe, because this is a very demanding task from the technological and from the resources point of view. So we are trying to work as close as possible with partners in Flanders, in Belgium, in Scotland, in the UK, in Norway, in Denmark. So it's one of our targets, trying to connect, trying to put in contact the industrial fabric in the Basque region, because the main target for us is to try to maintain or even increase the industrial employment in the Basque region. We are a very industrial region, and we don't want to put that industry level at risk. So that's why we are helping these companies that are in sectors that maybe they don't have this so promising future, trying to reorient their activities, to improve their processes, to train their people, and try to implement new products and new services in the offshore wind sector that I think may have a very long-term and very fruitful future for Europe. So from the, let's say, from the economy point of view, it's very important for us, this sector, but I would say that as a regional effort, we are trying to put the cluster and put our activities at the service of companies to maintain the employment and to maintain also the level of qualification and added value of these industrial jobs that we have nowadays. So this is very briefly said what we are trying to get out of the marine renewable energy future in terms of economic and social growth for our region. Thank you very much.
Thanks a lot for this very interesting presentation, showing interestingly that you may have noticed in the Green Deal that there is an emphasis put on the regional cooperation for the development of offshore energy, and this regional being understood that in the communication as regional cooperation between member states, but here it's very interesting and encouraging to see that the cooperation is also taking place between regions within the member states, and that's clearly an element that should play a strong role in the development of the activity. I will now give the floor to Mr. Brook from the Conference of Peripheral Maritime Regions. Please, the floor is yours.
Thank you very much, Thomas. I hope you can all hear and see me.
Loud and clear.
Loud and clear, very good.
I don't know, but hear you, yes.
So first of all, apologies on behalf of Eleni Mariano, Secretary General of CPMR, who could not take part in this meeting due to unforeseen circumstances. She has kindly forwarded on her speech, which I have revised, so I'm prepared to say what Eleni would have said to you at this important event. I think most of you know who we are, the CPMR. We're one of the largest association of regions in Europe. We're a lobbying organization representing 150 different regions from the different sea basins that you mentioned, actually, Thomas, in your introduction. And basically, our role is really to increase, if you like, the territorial dimension of EU policies and to reinforce the role of regions there as well. So first of all, I've got to say, we at CPMO, we certainly welcome the fact that the Commission is going to present a strategy to unleash the full potential of offshore renewable energy, which is really important when it comes to supporting a fair transition to climate neutrality for coastal and maritime regions. And also it's also very important in terms of ensuring the recovery from the current crisis we're going through. So that's the first thing I would say. I've got two main messages I think in the next few minutes that I would like to deliver in my short contribution. The first one, which is unsurprising, coming from an association like the CPMR, we would like this strategy for offshore renewable energy to really think about the territorial dimension. And by that, I mean a couple of things. First of all, if we want to reach, this is the title of this session, by the way, social and inclusive growth, economic and social cohesion, the strategy we need to ensure a fair transition to a climate neutral continent based on this territorial approach. This is important not just in terms of reaching the EU climate and energy objectives, but also to support the recovery of all coastal regions. So our message is quite clear. We have said since the Green Deal came about, we're saying that Green Deal legislation should recognize and rely on the potential of regions, which, Thomas, as you described in the introduction, is very varied depending on the location and the specificities and the sea basins therein. In terms of their natural strengths and resources, in order to create high-value jobs, which is very important at this point in time. So it's really important that the uptake of offshore energy follows a context-dependent approach that builds on the sea basins or territorial specificities. I was listening carefully to the first speech for this session from the Clean Energy for EU Islands Secretariat. We, of course, represent all of the European islands at CPMO, and I'm very, very happy to have heard his presentation defending the work of the Clean Energy for EU Islands Secretariat. So islands important, but also other specific territories like sparsely populated areas, but also outermost regions, and they all have their own challenges and opportunities. So we, as you've said again in your introduction, it looks like we coordinated. We didn't, but it's actually quite aligned. It's really important that the strategy actually, not only continues or supports development solutions that are successful already, like the offshore wind farms in the North Sea, but it should also promote and untap the potential that some of the other sea basins have. So, for example, the Atlantic coast when it comes to wave and tidal energy, and this is something that was mentioned in the previous session, but also specific areas in the Mediterranean and Baltic Sea. So basically, we would like the strategy to recognize this potential by sea basin. This was mentioned already. I have to mention something about the islands and outermost regions and the fact that there are indeed innovation labs, and we would like that to be clearly mentioned in the strategy. Having said all that, we are a little bit worried about the lack of detailed measures when it comes to marine renewables in the National Energy and Climate Plans, the NECPs. So we've done an analysis of the NECPs, and we see that only offshore wind is actually properly tackled, and we would like it to be a little bit more specific and broader. And likewise, when it comes to the investment guidelines that you see in the Annex Ds of the country reports, there's only one mention in one country of offshore renewable energy, and that's, I believe, Greece. And again, that would need to be reinforced or fixed. And that brings me on to my second main message, which is really we need an integrated approach at the European level to support offshore renewable energy and the broader blue economy. So this comes back to what I've just said about, if you want to support this really important sector, it needs to be done through the NECPs, it needs to be done by the investment guidelines, of the, as per the Annex Ds. But also we believe that it should be that there should be an integrated approach in different ways. And here I'm really happy that DG Mare published this really excellent 2020 Blue Economy report, which rightly recognizes the potential of the broader blue economy. It talks about 750 billion euros in 2018 in Europe alone, and it has the biggest potential when it comes to supporting Europe towards recovery. So when it comes to integrated approach, I mean a couple of things. First of all, it comes to, and this comes back to actually what Jose was saying a minute ago about the added value of clusters, but it's about really joining the dots when it comes to the blue industrial value chain, of which offshore renewable energy is part. So here, I've got to say, regions are key actors when it comes to develop clusters. I won't dwell on that too much because we had an excellent presentation a minute ago from Jose from the Basque Energy Cluster, very active member of the CPMR, by the way. And that is really important when it comes to realizing the Green Deal, but it's also very important when it comes to creating, adding value when it comes to skills or job creation. And it's really, really important in this current context. I would give you more example, but I think I would be a little bit too long. And secondly, we feel that the role that regions can play in that regard should not be overlooked. Think about the role of regional authorities in terms of competencies, so to support SMEs, skills in some member states, managing structural funds, European structural investment funds, for instance, on the one hand, in terms of competencies, but also legislative powers like coastal zone management, maritime spatial planning, for example. And this is essentially our main message. We're regions, we are the connecting dots between EU policies, on the one hand, the targets, the objectives, but also, on the other hand, the social and economic regional fabric, so to speak. And our message all along has been that the Green Deal has to recognize that. And it has in some ways, but we feel it could be a little bit improved. Finally, I'll conclude by saying that we're encouraged by the European Commission's new industrial strategy for Europe, which I have to mention. Here, it was published in March earlier this year. We like the fact that it raises an important point about a partnership approach to governance. We will organize, by the way, an event later on this year, at the end of September, in the Parliament to promote that and the wider maritime industries and the role that regions play in promoting these industries as well. But we certainly see that as a step in the right direction. And finally, just last word for me, as you may have seen, we have warmly welcomed the European Commission's proposal for a revised EU budget for the next period as part of a broader recovery plan for Europe. And it shows in a way, this is what we've said politically, it shows ambition and realism and the fact that there's a bit of a step change when it comes to Europe supporting its key sectors. And we're very happy that that's the way that the Commission has addressed that. And we hope that member states will follow suit at the end of next week, actually, at the next European Council meeting. So again, thank you very much for your for inviting the CPMR at this meeting.
Hello, I think we will take still at least, we'll take 20 minutes more to give time to the two last speakers, of course, to make their presentations, and then for a last round of Q&As. I will just reverse the order. I will ask Rémi Gruet from Ocean Energy Europe to make his presentation. If you then perhaps limit yourself to 5 minutes straight.
Okay, I'll try to do that. Yeah. Thank you.
Thank you.
So this morning I spoke about the economic opportunity. And now, next slide, please. I will speak about the social opportunity for Europe from ocean energy. So specifically wave and tidal and OTEC. Next, please. So when you talk about the social opportunity, well, there is, of course, the figures that I presented this morning, 400,000 European jobs that could be developed by 2050 in Europe. But it's also not only a matter of how many, it's also a matter of where they are, a matter of where they come from, and a matter of what skills they actually represent. So I'll start with the where they are. Next, please. Next slide. Yeah, thank you. Because ocean energy has a great potential to revitalize coastal areas. A number of those have been hard hit by the crisis. I've shown you this morning this map of the supply chain. The existing today's supply chain is very low deployment. If you look at the offshore wind map from the same source, it's very, very large, and we very much hope to get there as well. All of these have strong local content elements. In fact, now you can go to the next slide. Thank you. Very strong local content. Last year, we published a report from the European Technology Innovation Platform for Ocean Energy, which stated that European companies use about 87% of European content on average for ocean energy projects. And I can guarantee that if you go and see this ratio for the automotive industry or the plane industry, or maybe even our colleagues from the gas industry, you will see that they are well below that. Two examples, Sabella, who just presented earlier, a French company, 100% EU content, 80% French content. Nova Innovation, who did not present earlier, but a Scottish company, have similar ratios, and on top of it, they installed their machines in the Shetland Islands, so between Norway and Scotland, in the middle of the sea, and they still managed to use 67% Shetland content. So very strong use of the local workforce and amenities. Next, please. A second point on where it comes from are the local impacts on port authorities. Again, some ports dealing with defense, dealing with freight, dealing with oil and gas have also seen reduced economic activity, and they're reorienting themselves. And you can see here on this area on the top left is an area reserved for offshore wind, and on the right is an area that is reserved for offshore renewables generally. Next, please. If you can see, this is just the same harbor. It's a Cherbourg harbor in France, in the channel. And you can see that these two areas, so the green one and the purple one, make up most, basically, of the grounds owned and operated by the port authorities. And they're already reserved and geared towards offshore renewables. Next, please. So beyond the localization, then the next question is to wonder about where the opportunities come from and where the jobs can come from. And typically, we're going to make use of offshore, of course, new industries like offshore wind. We can use their skill sets, but we also use people from the oil and gas industry, from shipbuilding, and even from fishing industry to a certain extent. Next, please. To give you a few examples, when we wanted to build in 2016 the first tidal farm-based project financed, we weren't sure where to build it. So Atlantis, a company who was operating the project, went to this shipyard, which was an oil and gas maintenance shipyard for offshore oil platforms, and asked them whether they could do it. And basically, the skills they had are handling metal, welding, heavy loads, carrying heavy loads, and building strong metal structures were perfect for the purpose. So it's an oil and gas shipyard who built the first renewable energy tidal farm. Next, please. So beyond oil and gas, of course, we need ships, and we need different types of ships. We can make use of standard ships, and increased activity in ocean energy will mean increased activity in the shipping industry for cable layers, as you see on the left, or for tugboats and standard maintenance vessels, as you can see on the right. Next, please. But we also need custom-made designs, custom-made ships. You've probably seen the huge jack-up barges that are being used by the offshore wind sector by now. A lot of them are custom designed. Some of them are using old platforms. We have similar needs, not quite just yet. And I really want to tell you about Jason, who's the guy you see on this picture, not from a reality TV perspective, but Jason is the CEO of Green Marine, which is a company that was owning a small fleet of fishing vessels 10 years ago. And when offshore energy, and specifically tidal and wave, became a reality in the Orkney Islands north of Scotland, he decided to progressively sell his entire fleet and buy into a fleet of vessels that would cater for this specific industry. And they're vessels that are very multi-purpose, they're multi-cat vessels, in fact, and they can carry the turbines because of the foundation, they can crane them up and down, they can also pull barges. This is another barge that's been custom designed and modified to be able to carry turbines over there. So a great opportunity as well for new types of ships. Next, please. And finally, on the ship side, there is the whole repurposing potential. And this is a Spanish company called Magallanes. They basically bought up an old vessel and are using it as floater for 2 tidal turbines that are underneath it. And this is a project that's in the water at the moment, and also potential new life for old ships that are no longer operable. Next, please. So this was a bit to give you an overview of where this can come from, all these jobs, and where the activity can come from existing sectors. And then to finish, I want to talk about skills and want to show that we can use a wealth of existing skills. There is, in fact, little need at the moment at the level of deployment of our industry, and for the foreseeable future, there is little need for retraining, for reskilling, for huge programs on that. There is a need for market visibility, as you've heard, and finance. Next, please. I just wanted to show you a few pictures. What do we need? We need welders. Clearly, metal is still a very strong component in all of the wave and tidal devices. We use other materials as well, but metal is still very present. This is a device being built which will go in water in January next year. Yes, next, please. Thank you. We need crane operators. We need staff that's operating on ports. I've already mentioned that several times. Whether you crane up this device, which is a floater with 3 tidal turbines on it, or an offshore wind tube, or oil and gas equipment, it's basically the same job. Next, please. We need cable layers. Obviously, all of the turbines need to be connected to the grid. Next, please. We need divers, not only for the cables, as you can see in the picture, but also for simply help with installing the devices, monitoring of the devices, any type of surveys on ground sounding, etc. And finally, next please, we need engineers to design all of the above, and not the kind of engineers you find on the net who are wearing hard hats in the middle of their office. Next please. But if you want to meet the real engineers behind the offshore industry and the wave and tidal industry, then please join us in Brussels on the 1st and 2nd of December. We're going to have our conference, hopefully physically, here in Brussels, and then you can meet everybody. We're probably going to have a partnership with ARENA as well as part of the conference, who are the International Renewable Energy Agency, with whom we partner for a number of initiatives. So it should be a very interesting event. And next and final slide. Thank you. So if you retain 4 things on the social aspects, then please do retain these. You have 4 opportunities with Ocean Energy currently. You have the opportunity to create a large number of jobs, 400,000. You have an opportunity for coastal regions who've been hard hit. You have new opportunities for old industries. And finally, you have the opportunity to reuse a wealth of existing skills that we boast at European level. So let's seize all of those. Thank you very much.
Thanks a lot, Remy, for the very interesting presentation, and again to stick to the time. And we are now reaching the last presentation, but not the least one, by Frank Gillen from InnoEnergy.
Thank you.
And if you can stick to really 5 minutes.
Yeah, I will do that. So, thank you. So my name is Frank Gillen. I'm Education Director at InnoEnergy. And I think most of you know InnoEnergy as an investor and an innovation driver in the sustainable energy transition. But the nice thing is that we invest both in with financial capital, but also human capital. And that's the point I will cover today. Next slide, please. Next slide. Yes, so if one of the missions of InnoEnergy is to create impact faster and sooner, and for doing that we need to move more people faster and sooner, more human capital in the sustainable energy sector. And it's important to know that InnoEnergy mainly focuses on the higher education segment, so targeting the special breed of engineers that you would need in, as from the previous speaker. So next slide. Now, when we look at the skills that are needed in the energy transition, but also in a lot of the specific work on offshore work, we always come to the same elements. From an engineering perspective, there's a big impact by decentralization. And so we have a lot of programs that focus on what does it mean technically, but also from a business model point of view, to move into decentralization. And specifically today, one of the hot topics which we are covering is the combination of storage and offshore wind, and also the combination of hydrogen, green hydrogen, and offshore. But when you do the skill gap analysis, and for this we have developed a platform which actually is released today. So if any of you are interested, I can send the link to the organizers who can distribute this. But what we do is we analyze the technology trends, the roadmaps, all the publications on job foresight, and then we extract the skills that are like the top 1, 2, 3 needed in a certain sector. And when we look at wind energy in general, digitalization is always coming out as #1. So we also have a lot of attention for developing the digital skills that are needed by the engineers in this sector. And it's digital skills in all phases of development. It can be in the planning phase, doing the forecasting on how to implement a wind farm, but it's also in the operation and maintenance phase, so using big data and AI to predict maintenance or to optimize maintenance crews flying out to wind parks. So those are the typical skills which are needed. But of course, we don't want that energy engineers have to become computer scientists for this. So this is exactly where we try to provide a solution. Teach the skills that are needed for a particular environment and context. So next slide, please. Next slide, please. So the other thing which is important in the training and the skills that we see is that in the entire environment of the energy transition, there is a lot of unpredictability and uncertainty. So we have created programs and training programs where students are specifically challenged to develop those skills, to make decisions under uncertain conditions, to make decisions with a lack of data, and making sure that still the progress and the innovation change linked to the transition is achieved. So next slide, please. Next slide. Now, one of the most important elements and unique selling points of the InnoEnergy training is that we have a very large network of companies, startups as well as established companies, in all segments of the value chain in all renewable and sustainable energy domains. So like in ocean energy, we have startups in wave energy, tidal energy like Minesto, Principal Power, floating offshore wind. And we use those network connections to train the students or to train our learners. And if you go to the next slide, you can see an example of what I'm meaning. This is a training project which we did together with EDPR on offshore wind, and using our startup, invested startup Principal Power, people on the platform, or actually our students who learn at sea on how to deal with numerous aspects of deploying this offshore wind, including technology, but also ecological and environmental issues like how to negotiate with the local fishermen who don't like these wind parks in their fishing grounds. So those are the main parts which we use. We use real projects and challenges and at the same time put students on there under a good level of coaching, so that they don't only learn, but at the same time they also start solving problems, which is one way of creating the impact sooner and faster. So I leave it at that. If you want to have more information, I can provide my contacts to the organizer, and as I said, I'm certainly willing to share the test link of our skill prediction engine, and you can test it for the wind sector because it has been trained with data for the wind sector. So thank you.
Thanks a lot, Frank. Can you hear me? Yes?
Yes.
Yes, okay. No, thanks a lot. Then, yeah, we'll make sure that your coordinates are available to any participants who would like to get in touch with you afterwards. So we are behind schedule, but still, I think this session deserves a round of questions to the speakers. There was a question from the audience directly to Mr. Jensen on the clean energy islands. I read it through. We see that islands are a strong market opportunity for ocean energy technologies to tap into. What can be done to accelerate the development of this potential in those islands? And here the person mentions, for instance, can we look at specific fast track consents for islands? And indeed, an important point, stronger community ownership and buy-in may also be a good vector to increase or accelerate those projects. So your reaction on this, please, Mr. Jensen.
Thank you, Thomas. I think to fast track things like this, it's I mean, it may sound like I'm repeating myself, but anchoring these ideas locally are very, very important for the future deployment of these renewable energy sources. I mean, it is the islanders' backyard. And to fast track further, I think from our side, we have sort of the bottom-up approach, but at the same time, the Clean Energy for EU Island Secretariat is tightly connected to both the island activities going on in the European Parliament, the island activities going on in the Committee of the Regions, and tightly, obviously, connected to the European Commission, who's coordinating this. And lately also to the member states within the memorandum of split, where the island member states have further emphasized the importance of focusing on islands and connecting these levels of governance and sort of increasing the awareness of the importance of renewables deployment on all levels at the same time. So we all speak the same language. From regardless of who has the mandate to plan and regulate and deploy. I think that is something that we have to look into in the future, much more than now. Many are doing it already, but much more is needed, I think. And then I think a certain point is like coming back again and again to the ownership. There is something that will also be sort of an open question to the other panelists here from today. It's an important thing also looking at, because the innovation pace that's going on when it comes to offshore renewables is very fast, and it also increases the size of the projects, and keep the local communities into consideration there too. What's their buy-in of large wind farms, for instance? It's important that perhaps they might not have the buying power to own it anymore because the investments are becoming so big. But at the same time, what's the benefit of the community? I think that investing in the community will come back tenfold also when it comes to deployment of large renewables offshore.
Thank you. Thank you for your answer. I will direct to Mr. José Hormarche from the Basque Energy Cluster. Here, maybe we notice that the SME dimension is critical in the value chain and ecosystem within your region. What's in your view the let's say if you had only two keywords or key proposals for improving the situation for those SMEs, what would be the key European measure that would be most helping?
I don't have any doubt about the first one. I would think the second one, but the first one is to provide access to these SMEs, to these, in some cases, entrepreneurs, and in some other cases, traditional SMEs that has a long experience in specific knowledge areas and specific skills. But the great thing to do for them is to provide them access to these big, the previous speaker was talking about the big projects, big infrastructures, big companies. In Europe, we are lucky to have some of the main leaders in offshore wind, in wave energy. So what these SMEs need is to have the access to these big companies, to show them their skills, to get the feedback of the demands, I mean, the challenges that these big companies are facing in the big projects they are developing, in the infrastructures that are being built in Europe, because many of these SMEs could be able to support them to solve many of these challenges, but they need that interaction. I mean, that's one of our key missions as a cluster, to be able to find the right partners or the main customers or the main developers in different regions. That's why we are insisting in the interregional collaboration, because sometimes we have to go finding these big companies and big projects wherever they are, mostly in the north of Europe. So that's why we are so active in partnering with North European regions, clusters, and companies, because what our SMEs need is that direct link to learn from the big companies in the sector, but also to offer them their skills. And secondly, one of the things, the second thing maybe I would say is that we could ask, or that those SMEs need, let's say, regulatory or administrative easy environments to operate. I mean, in some cases also we have to help companies when they change the country or the market. They have to start almost from scratch in some issues that should not be so relevant, but they have to, I mean, get certifications or get different kinds of contracts that or requirements in specific markets, even internally in Europe. So I would say those administrative certifications would be also a way to simplify or to help the SMEs to operate easily, let's say, all along Europe. But the first one, I will insist again, the connection, the access to these big leaders we have in Europe.
Thanks a lot, very clear. One question now to Mr. Brooks from the CPRM. Here, maybe would you have a view on the potential of the Balkans or the Black Sea regions in terms of offshore energy, wind, and offshore energy development, but also what would be the potential and the benefits for those regions in particular?
There was something written on my speech that I forgot to mention, which was that because I'm replacing Eleni and I'm not an expert on offshore wind, offshore renewables, please be nice to me when it comes to the questions. But I forgot to read it out. I think the only thing I would say, that I've heard from our members in the Balkan and the Black Sea commissions of the CPMR. We need to involve them in the energy transition. We need to show them the benefits of going carbon neutral, going climate neutral rather. but this comes back to the point I was making earlier about the need for a decentralized approach and a recognition in that strategy that the potential when it comes to offshore renewable varies from one sea basin to another, and so the message I would have is that they need targeted support, but when it comes to, for example, to capacity building skills, things like that, they're clearly not at the same level, and that was raised by other colleagues. They're not, you can't compare them yet to North Sea or the Baltic Sea when it comes to sea basins, but this is where you would need an integrated approach. You would need to foster perhaps exchange of best practices between various sea basins and projects, for example. So I would stop there because this is well beyond my area of expertise.
Okay, but these are, it shows the interest, and it was stressed by the previous speaker that there must have clearly cooperation between regions to share their experience, their knowledge, and that's a critical element. Of course,
Indeed.
taking into account the specificities of the of each location and sea basins, but there are many elements and acquired experience which could be shared to allow accelerating or facilitating the scale up of renewable energies in the different sea basins.
Absolutely.
So thanks for this answer. And then a last question to Remy Grue, since Frank Gillen had to leave the meeting. Yes, so Remy, you said that in fact you don't feel that there is such a need for skilling or creating new skills, but more to reorient or redirect the existing skills to the offshore activities. This it's based. You really have this view EU-wide, or it's maybe based on where the so far the offshore energy has been developed. But do you think that it would be the case also in those regions where it's still an area to develop, and maybe there is not yet any, maybe there is not yet the available skills from really the technical level to the engineering steps. But so it was just to precise, in fact, the scope of your statement. That's really, you think it's something European-wide, and there is no real need to reinforce or to explore some policy approaches for these aspects.
Okay, well, first, just let me precise that my statement is towards ocean energy, so tidal wave and OTEC. It doesn't concern offshore wind. It's very possible that the offshore wind sector requires more training than we do at the moment. Most of the people we've hired so far are coming from the oil and gas sector. They're coming from offshore wind. They're coming from fisheries and shipping industries, as I mentioned. So at the moment, this is what we witness in the areas where we are present. Now, I am unlikely to have a lot of information about areas where the sector is not present yet, because the sector is not there yet. So maybe as these areas develop, we'll see whether there is a need that arises. But I guess my advice is to not put one thing before the other. What is required now for ocean energy is to pass the valley of death and kickstart the sectors into pre-commercial and commercialization. Once we have that, we can worry about whether we have enough skills. My personal feeling is that given the oil and gas fields in the North Sea are shutting down one after the other, there will be a quite large amount of workforce that will be looking for jobs. And maybe the oil and gas executives will have to adapt to salaries in renewables, where we can't control the entire market. But in the end, I think we will find a good workforce there in terms of skills that's going to be qualified. And so far, it's proven a good strategy. In fact, the last person I hired myself here comes from Shell. So yeah, I think, this is my answer, basically.
Okay, thank you. Very enlightening. So I think this will be the final word for this session and then for this webinar. We are, yes, 25 minutes beyond schedule. Thanks a lot for all of you for having remained up to the end. I hope you found this day interesting and in order to understand the scope and ambition of the strategy, but also, and I could see it through the chat, I think, to establish some links between yourselves. And this, I saw that it was lively, and that's very welcome. So to conclude rapidly, this webinar is part of the public consultation process, which is feeding into the drafting of the strategy. It will be complemented by online consultation, which is now to be issued very soon in July, where you will have the opportunity to reply to an online questionnaire and also to raise points you may have specifically given your field of activities. So we really encourage you strongly to contribute to this questionnaire, which will be a key input. And frankly speaking, today, seeing the richness of the discussion we had, we really look forward for the input you will make again in this questionnaire. And final word, thank you all for your active participation, and a special thank to our two colleagues, Pablo Riesgo and Christophe Goujon, who's been the ones behind, but playing a key role to facilitate and to ensure that this whole webinar was, as you could experience, smooth and I think very clear for all of you in terms of clarity of the video and the sound, and also in organizing the discussion. So a big thank to you too, and for the whole, also all the colleagues within the Commission who supported from a technical or in let's say substantial input for the organization of the event. So thanks to you all. We really look forward getting back to you in several weeks or months once the strategy is out, since it will not be an endpoint, but on the contrary, a starting step for a process which will lead us up to 2050. So thanks again. Have a nice afternoon, and then see you through the online questionnaire of the public consultation. Thank you. Bye-bye.